Hi folks, in this video we're going to have a look at how you can work out what the magnification of a lens is. So the setup that we're going to use is the same setup that we'd used previously, where we have a lens, which is a converging lens, we have a screen on one side, and we have the object on the other side. Now the object in this case is a small washer with a cross in the middle. And then of course we have our lamp, which is the light source. So there's two different equations that we could use. We could use the fact that the magnification is equal to V divided by U. V is what's known as the image distance. That is the distance between the lens and the screen. And V is divided by U, which is the distance between the object and the lens. So we call that distance U. There is another way that we could find out the magnification of the lens, and that is by using the relationship between the size of the image and the size of the object. So the equation we use for that is M is equal to HI, where HI is the height of the image, and that's divided by HO, which is the height of the object. So remember, our object is here, and if we were to measure the height of that, that's HO, and the image is being formed here on the screen. So we can measure the height of that image. So before we begin, we'll measure the height of the object, which remains constant throughout the experiment. So all we do is just take a ruler and measure the diameter of the washer, which in this case is 22 millimeters. To measure the height of the image, you can simply place a ruler on the screen and measure the height of the image directly. However, by using a ruler, it can be quite tricky to not move the screen. So to avoid having to touch the screen at all, we could put a piece of graph paper onto the screen instead. Now each of the squares on this graph paper is equal to 1 millimeter. This makes it much easier to read the height of the image without having to actually touch the apparatus in any way. So in order to collect the data for this experiment, we first start off with our object distance U of 15 centimeters. We then adjust the screen until we get a sharp image formed, and then we measure that distance V, and then we also measure the height of the image on the screen. Then, after it's been recorded in our table, we can adjust the original value for U, change it now to 20 centimeters, and again change the screen until we get a sharp image and measure the height of the image. And we repeat this for a range of values of U. Now that we have a set of data, the last step is to work out what the magnification of the lens is at these different points. So we have two equations that we mentioned earlier. We have that M is equal to V over U. So the image distance divided by the object distance. So I'm going to add this into the next column here in the table, V over U. And by performing that calculation, that will tell us what the magnification is of the lens at each of those stages. We also have the relationship that M is equal to HI over HO, which is the height of the image, divided by the height of the object. So notice that the values in our table for the height of the object are constant throughout because we didn't change that at all. But the height of the image did change. So in order to work out the magnification from that, that's going to give us the final column in the table, which is HI over HO. For each row in this table, we should find that the magnification is the same value. So you can pause the video here at this point and take down that table and work out those values just to show that the magnification is the same. And that's it. I hope you find this useful.